Okay, I think I'll begin. I'll just start by just saying this is the last session of day 3 of FIRE. This day is the Advanced AI Day. And the topic of this session is robotics and automation and service of society and economic well-being. I'm the moderator, and some of you may have heard me introduce myself a session prior to this, but I'm Ken Kreutz-Delgado, Professor Emeritus from the University of California, San Diego. That's a mouthful, so often I'll just say UCSD rather than UC San Diego. I'm Professor Emeritus. I'm retired there, though I still do research. And currently I'm a Senior Technical Fellow of Mathematics and Machine Learning at the company Pattern Computer, which is founded by Mark Anderson, who's currently the CEO. I hope you can join us at 5 p.m. when PCI will describe some of its recent discoveries. That'll be quite exciting. So we're looking forward to having you all participate. The procedure is there is a Q&A, but you're to put your questions initially as we go into the chat. And your questions will be answered during the 15-minute Q&A segment that opens up 15 minutes prior to the end of the session, which will be at 4:45. So beginning at 4:45, your questions will be answered, and you should feel free during that period to even put in more questions, and we'll get to as many as we can. So it's my great pleasure to welcome distinguished guest, Henrik Christensen. And Henrik is really quite an impressive fellow. He holds a Qualcomm's Chancellor's Chair of Robotic Systems at UCSD, as the Distinguished Professor of Computer Science at UCSD. And he has an extensive and impressive background in robotics and automation, both in academia and in industry. Among his many accomplishments, he's the founding director of the UCSD Contextual Robotics Institute. Context is important. So Contextual Robotics Institute, we refer to often as the CRI. And he's the co-founder of ROBO Global, an AI robotics automation investment advisory company that advises investors how to best put their money in these emerging new technologies. So he also consults and regularly reports to parts of the US government. So Henrik, welcome. Okay, so.
Thank you. Oh. Thank you for having me.
Oh, thank you for being here. So thematically, I'm just going to say, because we only have 45 minutes, so I'm being ambitious, but thematically, it'd be nice if the session could follow a sequence of topics focused on AI-centric automation. And in particular, they're kind of high-level themes. I'm interested in how it can empower people, how it can empower, and this is related to the first, how it can empower education, okay, because education is critical for the first, empowering people, and for the third topic, which is how do we empower our national economy. And the fourth topic, if we had time, would be, can robotics and automation also empower the US to become, again, the way it was, say, immediately post-World War II, as a beacon of strong, positive leadership in the world when there's a competitive of ways of acting and being in the world being presented to the world by China and others. So that's a fourth topic we may or may not have time to touch on. But to begin with, perhaps you can tell us a bit about the Contextual Robotics Institute. What does it mean by context? What does it mean that you're interested in human-centered issues and concerns with automation as it impacts all aspects of society?
Sure, Ken. So for me, context is very much about, we can build the best gadgets in the world. If you don't think about them in the context, they might be completely useful or useless. So it's more, if I'm thinking about, I know Larry, who's on the call here, has a Tesla, and I'm sure it's fully autonomous and it's all of this. He's going to be stuck on I-5 just like the rest of us when he goes home from work, because, you know, unless we have not only thought about an autonomous driving car, but how do I integrate it into a traffic ecosystem? How do I understand traffic? How do I understand all of these things? He's just as stuck as the rest of us. He doesn't have to sit there with a wheel. But so context is about, how do I build technologies that considers the full context? And the context is, how does it integrate into a system? how is it being used by people, and how do we sort of make sure that we optimize it and learn over time. So context is very important in all aspects. Like, if I think about one of the things we work on is a robot that helps elderly people in their home. But most of the robots that have sort of been designed are useless in the sense that, the user interfaces are terrible. So if you take it, something like a good example is the first Roomba, which was designed and had 3 buttons on it. It has on off, then it has size of the room, and then it has spot cleaning. And of course, the size of the room was small, medium, and large. And everybody will call in to the support line and say, what's a large? And we need to be much better at doing this. Don't leave this to people because they can't understand it. I had the same problem when I was actually on the team that developed the first autonomous vacuum cleaner 5 years before the Roomba. And I designed it and I was super proud of it. And I gave it to my mom and she called me up and she said, Henrik, it's not working. It's running around in circles. What do I do? I said, oh, it's not a problem. You go in and you press, on the 3rd menu button, and then it'll go back to normal. And her first question was, what's a menu doing in my vacuum cleaner? So it was a clear sort of cultural change. She's never used a computer. For her, a menu is something she gets in a restaurant, not something that exists in her vacuum cleaner. So we need to contextualize it to make sure that we understand who is our customer, how do we do this the right way, and embed it. So whether it's autonomous driving cars, it's home appliances, or it's doing manufacturing. Every time, it's not enough that you just build the robot. You need to build that entire system around it. So what we do at UCSD is we develop systems that are for the future of manufacturing. We do systems that are for the future of surgery, and we do systems that are sort of for the future of autonomous vehicles. It could be autonomous driving cars, like you heard about a couple of hours ago, but it could also be autonomous flying vehicles. So to give you an example for autonomous flying vehicles, I used to fly a lot and go to the East Coast. It's typically 4 hours. The average engagement time for a 737 pilot is 17 minutes. So, for the remaining 3 hours and 45 minutes, they play, Angry Ducks or whatever they're playing, Angry Birds up front. So what do you do? So this is a terrible sort of integration of people where you basically said, I need you for 5 minutes in the beginning and I need you for 5 minutes and the rest of the time you can do sort of whatever you want to do. So we need to find ways of integrating these systems in a much better way so that they feel. And I was just mentioning to Ken before, so the session you had with Mohan Trivedi, the average user, when they take up their cell phone and they look at it and they put it down, it takes you about 25 seconds before you're fully contextual aware again. This is really dangerous. If you think about how far you drive in 25 seconds, this is really scary. And most kids say, oh, come on, I just looked at the phone, I got a really important text. Yeah, okay, 25 seconds of important text, or is this really good? So we need to be better at building systems. So for us, the marriage between systems, robots, and people is sort of holy, and that's what we're working on.
Yeah, so that context is actually much larger than just saying, oh, here's this manufacturing plant, or here's this domain. This context really is everything. It's human beings, it's the environment, it's the robotic system. So it's context in the large. How did this come into being? I mean, you're unique, right? There's no other robotics institute that has context in its moniker. I mean, isn't this kind of built into doing robotics, or did you really have to make this a centerpiece because people were missing aspects of robotics?
So I'm going to say something that's not politically correct, but I think most robotics institutions are hosted entirely in an engineering school. Mm-hmm. And I think that's a problem. So because a lot of this, when we build systems, we have to think about so many other aspects. It's not enough that, I can build one of these and it looks really cool, but can I also understand how does it interface to people? Can I understand what is a reasonable cost for this? But also, can I understand the ethical aspects? What about, are they recording me? Are they doing? So we need to be able to build robotic systems that are much more multidisciplinary. And for me, when I got to UCSD, it's very interesting. We have strong collaboration with the Cox-I department. We work with the policy people, and we work with Rady, the School of Economics, because we need all of these aspects. It's not enough that you can build a really cool gadget. If you don't understand the rest, you're not going to be successful.
So from the outset, then, you were thinking this is much bigger than the School of Engineering. From the outset, it was
sure
to be. I see. So all these agents you're just talking about, they're integrated into the Contextual Robotics Institute. They're not just like, hey, are you interested in this problem? Oh, can you suggest a problem? They're front and center. They're engaged.
Right.
Day one.
No, they have. So we have faculty from Cox-I, we have faculty from Rady, we have faculty from, we have somebody from practical ethics involved, and I think that's very important. And I would love to have more, because at the same time, I would love to have more business people also, because too many things are sort of invented where people don't understand the business case. Okay. And you mentioned things that this is really, really cool if you could do it for 10% of the cost, and you would understand how do you integrate it. So I think it's very important for the long-term success that we really think about this as being a multi-objective optimization problem. It has to fit people. It has to be a reasonable cost. So the first vacuum cleaner I built, as I mentioned earlier, was sort of what I would call the Rolls-Royce of vacuum cleaners. It was really good at cleaning, but it was too expensive. And that was why, not everybody needs a Rolls-Royce. They need a Volkswagen. And that's sort of what the Roomba is. It's a good enough cleaner. But as engineers, we need to understand this totality to be successful.
So you engage with the Rady School, and a lot of people are interested in human psychology, human factors. So you really then imagine not just doing science cross science, which is important, but you imagine in the end, there is in some sense a business case that they can get out into the world and really have an impact right away, as soon as possible. You think in those terms.
Sure, but also, so it's not enough to do good science. I'm also saying it's very important for all of us to understand, how do I do translation? Yeah. So the sad fact is that I would say 10% of what we do at universities are translated, because in many cases we don't have the link all the way out to how do I find a viable entrepreneur? How do I find the money? How do I build all of this? And that's an important part of doing this. We need to be able to do the full spectrum to be successful.
Yeah, well, I just retired after 35 years in academia, and I can tell you innumerable times I'd meet people in the industry who'd say, well, what do you know? You're just an academic. You don't understand how the real world works. You don't understand what my problems are. You're not going to give me anything that's monetizable or it's going to have any impact in the marketplace. So right. That's kind of a bias I'd always have to act against. Had you ever encountered that yourself?
So I'll give you the example. 15 years ago, I went to the White House to talk to Tom Khalil, who is the director of policy in the Obama administration. And I walked into the room and Tom said, oh, you are one of those guys that are, robots, they kill jobs. Why would I want to talk to you? And then I said, no, you don't understand. I help bring manufacturing back to the US. I help improve the quality of healthcare without increasing the cost. And I secure our first responders. And then Tom said, okay, we need to talk. And understanding all of this of how do you build it is incredibly important. But you will often encounter it. I'm in the camp where I founded 6 companies by now, so I've sort of had this. I'm having this experience of how do you do this, because I think that's important. But that's also what I think is important, that I, as an educator, teach our students. It's not enough that you can write sort of a differential equation. Nobody cares if you can't tell me. Why would I care? And that's, we need to be much better at this. How do we care? How do we do this the right way?
Well, thank you for setting such a great context on what the CIC Contextual Robotics Institute's all about. So let's just start to see if we can get through some of these themes. Basically, the use of autonomy and robotics to empower people. What's that mean for you? I mean, how can you empower people using automation and robotics?
Oh, so I think there's, So for us, if we sort of look at the different areas, we look, so in manufacturing, it's often about heavy lifting. So there are jobs that are sort of repetitive, and people get sort of repetitive stress injury. And in many cases, you can't do it well enough. So that's where you would want the robots to take in. There are other jobs where the complexity of this makes it very hard to automate. So we should take what we call the dirty, dull, and the dangerous, and we should sort of take those out and have robots do this while people actually focus on the places where we are better than this. So that's sort of in manufacturing. If we look at something like my argument is we should empower people from cradle to grave. So I would love to have robots that will help people with relatively simple things like, so I have see a lot of people that are mobility impaired. It's very hard for them to take a tray and actually carry it to the coffee table or to the dinner table. But what if I could have a robot? I could just put the tray on it and say, go to the dinner table, and then you will follow along. And then you can now stay much longer in your home or in your local social context without having to go to a managed care facility. So that would be an example. How can I help people, get out of bed, get dressed, take a bath, prepare a simple meal? These are examples of things that we would like to be able to do with robots, so that people can have, the choice of how do I optimize quality of life for me on my terms. And so that's another example. And of course, we see it for entertainment. We're seeing the same thing. You can now use robots to actually do things that would be very hard to do if you didn't have robotic systems. So the empowerment is very much about giving you freedom to do what you want to do at an affordable cost, and then taking away sort of the tedious part of the daily life. Whether it's cooking or cleaning or whatever it is that you say, I don't want to do that.
But segueing into the next two themes, if you take away too much, and it's not just the dull and the dangerous. I mean, you could imagine automating a lot of what accountants do, right? The question is what's going to be the quality of life, or how empowered am I going to feel if suddenly I don't have a job because a robot did take it away? Going back to, the thing that was put on you said some years back. So, I mean, to empower people has to give them a sense of fulfillment of their life, when they have to feel like automation and robotics is enhancing their sense of fulfillment, opportunity, and feeling good about themselves, right? So how do you move then to, once the dirty stuff is taken care of and even some of the rote stuff's taken care of, what will human beings do?
So let me start by saying that, so far I've not found an AI system that I cannot break in 10 seconds. So any said, give me, I will find a way of breaking. So these systems are still incredibly brittle. But the other one is also the level of penetration we've seen of automation today is still incredibly low. So if you go and, people think about lights out factories, that's a wonderful Hollywood dream, but it's not really anchored in reality. So even the most modern factories today for doing manufacturing have one robot for every 10 people. So there's still 10 people there. And the good news is, if we now look over the last 15 years on sort of economic growth, then we sort of say, whenever we grow jobs, we also grow robot sales. There's a strong correlation. When you invest in people and you invest in technology. There's very few cases where you go in and you totally try to replace people. There are a few cases. So mining is an example. Australia is doing a lot of things to do sort of replacement of mining, because it's very hostile environment, and it would be better if people are doing the stuff on upstairs rather than in the mine. But it's very few places where we do this. In most cases, it's the combination of this, but it is taking away sort of the tedious. And sometimes it's better for me to have an AI bot that checks my tax return and sort of say, hey, Henrik, you didn't do the right thing here, because that, there's really, these are sort of the tasks where I say you don't need a lot of intelligence to do this, because it's very routine, and you're sort of checking, was it a dot rather than a comma or things like that. That is very hard for people. We're not that foolproof for doing this, but I see this fully automation very, very far into the future, because the world is inherently noisy. The world is inherently complex. And as an example, it's still been very hard for us to build systems that have common sense. So every time I can sort of use my common sense to go in and poke at a system and it sort of falls over immediately. There's very few places where we can afford this to happen in the real world. And for that reason, we still need people.
We need people. I guess, unless they basically become superseded by the amazing abilities of the automation we produce. But let's say that's in the long distant future.
Sure.
Here we need to educate people. So presumably education is an important factor to keeping us, getting us good jobs and having a meaningful life. And until the singularity, whatever you want to call it. So
Sure.
What do you view as the role of education? Is it meaningful? Is it important? And how do we get the type of quality education we need?
So, this is a hot topic for me. So because I don't feel our educational system is very good. And it probably, if I go back and look at, when I came to the US initially, I lived in Georgia. In Georgia, about 35% of a generation of young people never graduate high school. And that to me, that's a huge challenge, because what are we going to do? They need to have jobs. So we had, as an example, a Kia factory that moved to Georgia, and the CEO for Kia showed up and said, "You have to deliver people to me." And he said, "Oh, we have lots of people." And I said, I require that they can do basic calculations and they can read. And then I said, well, okay, we have a little bit of a problem. That's scary. If you can't guarantee that everybody in the US has a GED, that's a little bit scary to me. So I think, but also I think a lot of the education we do today is template based. Can you pass specific tests without actually doing this? So I'm a strong believer in, I have an education that was purely problem based. So I'm sort of saying you need to have a little bit of foundations that are sort of good enough. Then you need to be able to acquire knowledge, you need to be able to figure out where do I find knowledge, and then you need to be able to do problem solving. So a good example for me is I have a robotics class that I do, and I basically, over 10 weeks, I asked the students first, I said, you have to assemble it and make it move, and give them 2 weeks for this, make them move, and then they will come back to me and they will be very unhappy and say, this is a crappy robot you gave me, it's not very good, it runs all over the place. And then I teach them about feedback control. And then they're like, thank you. Now suddenly it can actually do something useful. And then I said, well, you need to be able to learn to teach it how to actually drive through the environment. So now they can drive through the environment. Then I teach them how can they plan a path. And then finally we teach them, said to them, all of these components you've had, you have to combine them to build the equivalent of a Roomba. So in 10 weeks, I take students that have never done robotics before, and I take them every time they run into a wall. They're like, I don't know how to do this. Then you teach them how to do this. So they're very problem driven of bringing together math, programming, all of these different aspects, and testing and all of this to do this. And after 10 weeks, they can program the equivalent of a Roomba. And I think that giving them this ability to recognize what is a problem, recognize where can I acquire the knowledge, show that you can apply it, and then go to the next thing is much more rewarding. So I think teaching them sort of math, philosophy, all of these individually, without teaching them how do you build sort of an umbrella that brings it together, is not helpful. So I think we need to rethink how we do education. I actually want to be more radical. I think we should rethink all of education, right? Because when I got my degree, at the university, the president said to me, gave me a diploma, and said, "Here you are, you're good for life." Man, was he lying? I was not good for life, because you need to continue to acquire knowledge. So my argument is we should have an educational model where you sign up for a membership, where you basically say, here is your membership card to UCSD or wherever, and it basically gives you the license to go back 4 hours every week and learn new knowledge. And that way, it's impossible. The world evolves exponentially, and for that reason, you need to be in a mode where you learn something continuously about how is the world evolving, how is technology evolving, how is ethics evolving, how is all of this. But it should be a natural part of your job that you're all the time learning new things. But then at the same time, I want to flip it around and say, we also need to then have teachers that actually make it interesting. Because, there's a lot of classes where you're like, oh, really, when is it over? So we need to have almost the equivalent of an entertainment model, but through this, you actually learn something. So as an example, I'm very interested in educational games. You might not know this, the average 20-year-old American has spent 12,000 hours playing computer games. That's 10% of their life without sleep, or 2 years of your life. If I could teach them something along this, rather than just how do you move your thumbs, that would be a fantastic model. People have tried this, but only for really simple things. So I think we need to get to a model where part of your daily activities is to grow your brain and learn new things. And through this, we can become much better than we are today.
So moving on then, how does the quality of education and the use of automation going to empower the national economy? What do you think are the wrong currently with our economy, and how can autonomy fix it?
So I'm not sure we can fix it through autonomy, but I think we can become much better at integrating these technologies. But also I think we need to sort of recognize where we are. So the US is incredibly good at inventing new technologies. We have high education, we have access to venture capital, and we have ways of building the early stuff. We are, in most cases, terrible at holding on to the technology. So if we look at it as an example, one of those that sort of shocked me is that if I ask most, I'm Danish, so I'm an import, but if I ask most of the Americans I know and said, automotive, US, big deal. Well, I have a wake-up call. The US is not in the top 5 automotive manufacturing countries in the world. We're top 6, but we're not top 5. China is 30% of all cars being manufactured worldwide. Then it's Germany, Japan, Korea, India, and then US. So it's a lot of these technologies that we have developed, but we've sort of let them go away. The same thing, with traditional sort of industrial robotics. We don't build any of these in the US anymore. They're made in China, they're made in Germany, made in Sweden. So we have to sort of decide for ourselves, do we want to build technologies and do we want to own it? Or do we want to be at the top of the empire developing technologies and let it spill out and then let others sort of go and use them afterwards? So do we want to be the innovation economy, or do we want to have more solid technologies that we're developing? Right now, we've given away on cars, we've given away on chips, we've given away on all of these things that I think is very important. So we have to be strategic about what's important for us. What do we want to hold on to, and what are we willing to give away? So today, I would say we're very good at inventing new technologies, but we're terrible at doing this. So we're not the maintainers of technology, we are the innovators.
Which many people have commented on. So how do we become the retainers? I mean, I'm assuming that if we could become the retainers, there would be more economic opportunity for our workers, right? That we would bring jobs back, so to speak. I mean, when you talk to the people in government and some of the workshops you've been in, how do people propose we deal with this?
But I think some of it is also, so the good news is that some of it is changing in the sense that, the world is changing. So it used to be that the economy was largely sort of supply driven. So, so Ford, and as an example, would make cars and you would make it in a big factory and it would get shipped to you. And it was sort of one model of everything. The world is now flipping around to being a demand economy. So I don't want the same car that you have, Ken. I want my own car. So if you look at sort of a standard car available today, sort of an Audi or a Volkswagen or, Ford, that is typically available in 4 million different configurations. And this because I want different seats. I want a different audio system. I want different sort of all of these different things. And that implies that it used to be that everyone was built sort of mass manufactured And then it would make sense to make it in a country where you have cheap labor, you have a cheap production system, and you can afford to ship it to us. Now that we're getting to a point where you're shipping it, so I want something that's mine. And of course, at the same time, Amazon and other countries have taught me that I want it now. So when I press the buy button, I'm sort of like, now, when is it coming? And that makes it much harder to manufacture away from the US. So because of this sort of mass customization, and because it's individualized product, we want it here at the same time. So that is helping us of bringing it back. I'm saying the ultimate factory in the future will be an autonomous UPS truck driving around in my neighborhood with a 3D printer in the back, and I order something and it gets 3D printed on its way to me.
Historically, we talked about globalization is good because you could exploit comparative advantage, right? But now we're saying, let's bring the jobs back. And that kind of gets into the realm of autarky, right? Where basically you just focus on, I want to be so self-sufficient, I don't need the rest of the world, right? And there's a cost to that too. So in some sense, what's the right balance then that you have? What's the balance between self-sufficiency, so and that provides jobs locally, but also gaining the benefit of globalization? Is there some way to actually understand it? You can go to the extremes in one direction, too much globalization, we lose all our jobs, or too much, basically we demand self-sufficiency to the point where we put barriers up. Is there a balance, you think?
No, I think there is a balance, but also I think, but it's also, in most cases, we don't think about this as being a full optimization, because you also have to think about what is the cost on climate for transporting things from around the world. So you have to think about all of these different aspects and figure out there's certain things we want to do, which I would say because of labor cost, you have to sort of be careful for. You want to do things that has high value and you can have a reasonable level of automation, and things that is sort of mass manufactured, you want to be able to say we can't compete on those because we have salaries that are higher, we have certain qualities, but at the same time you then have to take into account what is the cost of shipping it to us in terms of environmental impact. And I think as we go forward, climate will have a continuing rise in terms of the impact on what we're willing to pay for and what is affordable. So because of this, I don't think there is sort of a unique answer, but I think we have to be very careful about what do we want to own, what are we willing to give away, and at the same time, do we have the people that can manufacture it, and can we afford it?
And what's reasonable to actually be manufactured overseas, right? I mean, do we revert back to a mercantilism a la the 18th, 19th century, an autarky where we basically demand complete independence? Or do we accept we are an interconnected world and there's some way to get this right so that we benefit, the world benefits? Does autonomy have a role to play in this?
No, I think, but also I think there are things where we might not have the raw material for doing it. But also, I think we have to but I think we have to be strategic. So if you take something like, you might say we could make cell phones again, and we could make them here. Yeah, but the rest of the industry has left the country. So unless you have that, it's actually very hard to bring it back. So the same thing we saw, in the 60s, 70s, where the mills were basically getting initially to Eastern Europe, and then eventually they went to China. And said, now we can actually do customization. We can build all of these sort of fabrics and all of this locally. Yeah, but the rest of the industry is gone. So getting that back is actually not so easy. And that's where I think we need to be very strategic about, what supply chain are we willing to give up? And once you give it up, it's a very slow process of bringing it back. You can't just sort of say, hey, I could build a plant in California or in Texas or something like that, because it's not that realistic. It's very expensive to revitalize the full supply chain.
Yes. Now, recently you were involved, you're actually one of the creators, I believe, as well as a host of a workshop on automation. It was, you did under the auspices of the National Academy of Engineering. You had governmental leaders from DARPA, NSF, Army Research Lab, Office of Naval Research, the White House Office of Science Technology Policy, and corporate thought leaders, right, from Amazon and Boeing, among others. Can you describe the intent and themes of this workshop? What the point of the workshop was?
Sure. So it was a workshop about autonomy, where we really sort of wanted to bring together people to sort of talk about where are we on building autonomous systems, and what are, how close are we to building this. It's clear the areas where autonomous systems has a lot of value. If you're doing underwater sea exploration, if you're doing sort of climate control, some climate monitoring makes a lot of sense. But there are other areas where actually building autonomous systems is really hard. So I know from you talked to Mohan earlier about sort of building autonomous systems, and for autonomous cars, we're sort of talking about 5 levels of autonomy, from 0, which is no autonomy, to 5, where there's no steering wheel. The hardest part is actually to do sort of level 4 autonomy, where in some sense the system is autonomous, but if it gets in trouble, it can ask an operator and say, I'm coming up on some road work here, can you take over? And there, the problem is that predicting far enough into the future that this is going to happen is very important. And at the same time, figuring out how do we do it. So one of the things we were interested in is also how do we do what I would call sort of fluent autonomy, where you keep having people engaged enough that you can do this. And then it can be for very large sort of systems so that you actually have this. So we wanted to understand, how do we build a national agenda to make sure that we will be the leaders in the future of autonomous systems? There's no doubt we will get autonomous agriculture. So there's no need for a farmer to sit on a harvester anymore. We can do this autonomously if you're in Illinois and in a lot of these places. We can, in many cases, fly over large areas and do monitoring to see, for instance, in California, if we can do fire detection. But there are other areas where you want to be engaged because it requires you to do it well enough. And we wanted to understand from the Army, from the Navy, but also from manufacturing leaders, from all sorts of company leaders, where do you see this go? And then what is a national research agenda for how can we ensure that we are the leaders on this? It would be very hard for the DoD, as an example, to buy autonomy technology from China. It's not happening. So for that reason, we need to sort of continue to think about what is this, and we all see more and more of building sort of the simple technologies, and we want to figure out how do we do this, but also how do we figure out how to do this in such a way that that it's accessible. So I'm always saying most of the systems we're seeing that are being designed today for this level of autonomy are designed by 50-year-old white males, and I'm one of those. And I'm sort of like, that's not who the users are. And so it's not designed with a 20-year-old in mind that has sort of spent 12,000 hours playing computer games. So we need to be much better at designing the technology so that it can be used by the people that are out there. If you still look for something like factory automation, in many cases they're using character-based displays. And the people will come and look at me and say, did you stop developing this in the 70s? Because they can go home and play 3D games and it's super advanced, and the factory automation still looks like the Stone Age. So we need to find a way of building technologies that are for this. And we think autonomy is one of those where it'll have impact on air, sea, and ground. And we need to make sure we can be the leaders.
What you're seeing now, interesting enough, is a lot of people who are hungry for developing these technologies come from out of the United States. I mean, I was a recently retired professor, and I know what a large percentage of our graduate classes are actually enrolled from people from China and India and the Middle East. We just don't seem to be able to get as many Americans as we should interested in these technologies. There are a lot of other engineering technologies. Why do you think young people in America just don't seem to have that hunger or willingness to undergo the rigorous discipline of learning hardcore mathematics-based STEM? I mean, the reality is, if you made all the grad students disappear from the American academic research enterprise tomorrow, research would freeze. It would end. There are no Americans, not insufficient number of Americans who could sustain it. Why?
So it comes back to, I think our basic education is not rigorous enough. And in part, I don't think it's, I love the fact that, so I'm involved with, there is an organization Dean Kamen started called FIRST, Foundation for Increased Recognition of Science and Technology, where anywhere from all the way through K-12, you can get involved in doing this. In some sense, at the face, it looks like a robotics competition. They are building robots, but the most important part is really every year, the first Saturday in January, you will get a challenge. This could be, could you build a set of robots that can play basketball? And you give this to a set of high school students, and 8 weeks later, they have to deliver the robot. It's not, most of my graduate students refuse to do it because they say it's too hard. The high school students have no idea it's too hard. So they actually do it. And we have 100,000 students that do this in the US every year. But it's not really a robotics competition. It's an entrepreneurship competition, because you might design a really smart robot, but if you don't have also a team that does fundraising so you can pay for it, you have a team that does logistics so you can go to the local competitions, you have team that do marketing so you have smart team dresses and all of this. And we are not only evaluating the robots on, does it play basketball? We evaluate it on, do you have team spirit? Does it have robustness? Do you have, sustainability in your team so that you keep recruiting new students for this? So it's like running a startup. And I think the students love it, because even if this math thing is not for me, great, we can use you on the communication team, or we can use you on the fundraising team.
Yeah, this is great. We have only a couple of minutes where we're going to move into the Q&A portion. So I just want to remind everybody that they can add to the chat. And in fact, I could ask another question, but then I think we would actually run into the Q&A. So how should we end this? It's interesting. I saw a comment about it's cheaper in the US to hire foreign talent. I happen to know in Silicon Valley, a huge amount of the people in the Silicon Valley are making salaries of $300,000 plus a year, more than many people do who are accountants, etc., are basically PhDs from China, from India. So the thought that you can't make money as an American going to STEM is actually wrong. It's not true. There's a huge salaries. There are families in the Silicon Valley, husband and wife engineering families, that the combined income is $600,000-700,000 a year. Okay, it is not the case that that there's no money in this field, and therefore Americans aren't going to do it. I don't know why, but Americans do want to go into entertainment. They want to go into media. They want to go into sport. They want to go into law. They want to go into finance. They want to go into business. I know this because I live in an upper middle class neighborhood, a neighborhood of the highest social economic level. I know that children in my neighborhood, they, in some sense, view engineering as a super hard field. And why should I work that hard? It's not cool. It certainly isn't shown as cool on TV. So I happen to know that there's a lot of money to be made if you majored in engineering. But I do agree that it's not portrayed in a way that young people in America relate to. And what you just told me is, I think, a great path for starting to break that perception that young people have.
Sure. But also, I'm sort of saying, why can't we have a Hollywood show that's like the Big Bang Theory that was about physicists? Why can't I have a Hollywood show that's about STEM and about, how cool it is to do something? It's a family where they all work at Tesla or something like that, where, it's cool. Right now, it's boring. It's terrible. They solve linear systems.
Well, you live in our area. The high school in our area in Carmel Valley, 92130, is regularly rated the #1 public high school in the entire state of California, 40 million people. Okay. And I know what kids go into. Okay. I know an MD whose father told his son, don't go into science or medicine, you're a fool, go into finance. And the son was a brilliant mathematician and he followed his dad's advice. So I know people don't agree with this comment, and I know there are lots of people who love math and science. I'm one, I went into math and science, but I'm just saying there is a perception that the STEM path is very, very hard, okay, compared to what other paths.
I think that,
but at the same time,
Yeah,
go
sorry.
ahead.
Go on.
I think that this is actually a good time to break into Q&A because there's been a very lively discussion
Yes.
going on about all the different issues. So you guys, I think you guys are, you might win the award today for the panel with the most back and forth kind of like discussion. It's lit up the feed here, so it's hard to find the questions. But I think our first question is from John Delaney. John, are you with us? If he's not,
I'm here. I don't think it was the first by any means. But
Go for it.
well, I don't understand a lot about all of this, but I wonder to what extent long supply chains and shipping around the world and a global economy could in fact be tied to the stability of the way nations deal with one another. If we all begin manufacturing all our own stuff, what happens to the international order?
Exactly.
I mean, I don't even know enough to ask the question, Henrik, but I would love to hear your answer.
Sure. No. So I don't think we should manufacture everything, and certainly if we look at raw materials are not equally distributed around the world. So I think there are certain things you want to do, but and that's also where I think we have to figure out what are the things that it makes sense to manufacture in the US, and to me it has to do with this what I said, individualization of products, short supply chains in terms of where you do the final manufacturing, but other things you want to have manufactured. So there are things that are mass manufactured that they should be made where it makes the most sense, and then some of the final customization should be made closer to the customer. So I still think there's going to be an international trade system. Right now, I think we have not thought about what happens to the system if we get trade wars and things like that, where in some sense we shut off China for being able to manufacture certain chips. That then implies that suddenly it sort of escalated. So there were cars and things like that was actually very hard to do because most of those chips were actually made in Asia. So I think we need to be smarter about making the right decisions. I still think we'll have trade we will have logistics all over the world. We trade with each other because we all bring different things to the table. But I think we need to I think we should be better at having rational discussions about this rather than they're from the wrong country or something like that. So we need to have rational discussion of where does it make the most sense to make things, and then figure out at the same time, how do we organize supply chains? Things that you need that changes rapidly should make closer to home. Things that don't change very rapidly could be made anywhere.
I have one last question, and it'll be very quick. Do you think the underwater robots 25 years from now will be able to replicate themselves and actually heal themselves when they begin to misbehave?
So there's two different questions here. So I think we will have robots that will that could be. I don't think they're constructing themselves, but I think we can do underwater assembly because it's faster to do there. And I think we will get software systems that are resilient so that they can actually understand and learn from failures. We're already starting to see this with variants of reinforcement learning. So I think we will get that. I think a more interesting question, which was actually suggested to me by Jeff Bezos, because I asked him, why do you want to go to Mars? And he said, I don't want to go to Mars. What I want to do is I would like to build a space system that can go and do mining in the outer asteroid belt. And Earth becomes the limitation of being able to send stuff into space. So if I can build factories in outer space that can produce space goods so we can go and do mining in the rest of the universe, then we're winning. And I think doing something underwater is the first step in that direction.
all right, very cool. The next question that I can find in here there's still lively debate going on.
Good.
I think it's from Mark Prensky. And Prensky, you said you were going to kind of form that question a little bit.
I can, and thank you for the session, Henrik. Just as background, I come from the Sputnik era. So I was the first STEM push where I was a kid. I was a smart kid. Everybody says you have to go into math science. I did. It took me half my life to figure out I didn't want to, even though I still like it. I don't think we should push kids. I think the best way to, and I want your opinion back on this. I'm not going to just give a speech, but what if we asked every kid, what do you want to automate? I mean, maybe you want to automate game playing. Maybe you want to automate something else. Maybe, and let them do that. And then second, we didn't say, let's just do this in the United States. Let's just do this locally. We said, hey, we're all connected in the world. Let's build international teams to do these things. And the last piece I'll say about this is that First Robotics, which I am a huge fan of, does exactly what you described. It's very interested teams together, and then it says to them, do stupid things like shoot basketballs through hoops, do stupid things like throw frisbees. Instead of, why not make your teams and find hidden bombs, find landmines, find people in earthquakes. I mean, why do we just keep our kids away from real stuff and think that we have to gamify everything for them, which I totally don't agree with. I'm with Will Wright. It's too hard to make an engaging game about a deep subject. And we really underestimate what the kids are interested in. We underestimate it because everything is hard. It's hard to be Steph Curry. It's hard to be a good entertainer. It's hard to do any of these things. You have to really want to do it. So our job is not to interest the kids in STEM. It's to find the kids who are interested. If they're all in China, we'll form teams with Chinese. I mean, hey, we don't have to do it all.
No, Mark, and so Mark, first of all, I very much agree with you. I don't think all students should be STEM. That would be stupid. We also need doctors, and we need, lawyers, and we need all of these other things. But I think it's very important that we should try and understand what motivates kids, what makes them. But also, I think we have to fundamentally change our educational system so that we learn them. How do you acquire very basic knowledge? How do you teach them how to acquire knowledge, and how do you teach them to solve problems, whatever the problem is? I don't care whether it's an IRS tax return or
I'm gonna let
going to the moon. But then at the same time, I think one of the problems we have with some of these is also, like, if you look at something like First, I absolutely love First. I think it's great, but it's way too expensive. So this is sort of so if you look at it, a team to participate in a competition has to pay $15,000 to participate. If I have, if I go to Atlanta, a certain half of the city cannot afford to participate because they don't have $15,000 to put into this. So we also need to make this accessible so that everybody can participate. It can't just be the rich kids game. So I agree. We should find out what motivates the kids, and then we should teach them sort of basics of knowledge acquisition, whether it's for lawyers or whatever it is. And then I think we should. And then I agree, we should work on problems that we care about rather than playing basketball.
Good. I agree with everything except your middle part about the school part. The other two parts I agree with. We can talk offline. Thank you for your time.
Okay, yeah, great. Because I think we have time for one more question. We have one more question. So this might be a rare opportunity to get to all the questions, which is hard. Rennie Gleason had a question. You want to bring it up?
Hey there. Yeah. So having spent a significant chunk of my career selling sneakers to kids for Nike. I hear you with what's cool for kids. So the question here is divided and distracted attention a key focus in getting people to deep focus on hard topics? You talked about the 25-second delay to get back to focus with your mobile phone. You talked about 12,000 hours of video games, which right now seem to be optimizing for in-game purchases and microtransactions versus building new worlds. So do you have some thoughts on that? Any thoughts around attention and bringing focus back?
But I think I don't think we're using this to We're not asking the kids. So I think it's a short-term reward function, but you could turn this around to use it for something constructive, rather than, do I acquire 5,000 points, and what if you could actually do something constructive with those points? And the same, what if, we're seeing people that buy sort of things in the meta world for real money. I'm sort of like, they're fundamentally stupid. Why would I do that? So I think we should find a way of enriching the kids to actually doing something, and in part doing this and getting more points. But at the same time, you should also teach them that the harder part takes more attention. You can't just do, the short stuff. I still think we should build an educational model into it. Today we don't, I would claim, and because of this, it's only sort of short-term benefits, and it's not furthering us as a nation, and it's not helping our kids.
All right. Well, thank you, Henrik. That was a fantastic panel. It was probably, I'm amazed you guys all still have the energy to be so lively, but it's very fun that you do, because the chat debate was great. Ken, thank you so much for hosting. You make it easy for me, for moderating, I mean. And with that, we will conclude this session. We're out of time.